Hello, everyone. Thank you all for coming to my talk. My name is Matthias Dangl, and I work at ARS. And at ARS, it is my job to guide our clients on their journey to the cloud. Now, if that sounds overly fancy to you, don't worry. What it basically comes down to is I do trainings, for example, on how to design APIs, how to implement DevOps, and especially how to succeed in bringing applications and also even organizations into the cloud. Now, as you can imagine, there's a plethora of good or even best practices that I try to advise my clients on to follow regarding, for example, company culture, processes and approaches, and also, of course, the technical side, how to design applications such that they work well in the cloud. And fortunately, in this area, on this technical side, there is pretty concrete and broadly agreed upon set of 15 core rules to follow that I want to talk about today. But before we get to that, I want to talk about the motivation that organizations have for going into the cloud, because we need this motivation later on when we're talking about those 15 rules. So when organizations consider going into the cloud, they have certain goals. They try to achieve certain benefits. For example, cloud service providers often advertise that going into the cloud, that using their services will help organizations modernize and innovate. And while that is pretty generic, the idea that a lot of organizations have is that they might be able to build some kind of platform economy where they integrate the applications not only within their organization, but even across organizational borders, for example, with their partners or with their customers, and thereby also are able to develop new business opportunities. So that might be a goal here. It could also be much simpler. It could be about standardization and about process optimization, which is certainly something that is achievable via the cloud, and it's also a necessary criteria for going into the cloud. It might also be about making the workplace, so the organization as an employer, more attractive for their employees, right? To be able to say, we are a company that works with the cloud, that has applications in the cloud, that develops products in the cloud. Oftentimes, it's also about legacy products or technologies that an organization uses that are no longer continued by their vendors, that are discontinued. And in this case, they need to find some alternatives. And today, it's a fact that a lot of these alternatives are only available via the cloud. So that could also be a reason why an organization might be forced to go into the cloud. Another reason a lot of organizations state, or at least consider, is whether going into the cloud might help them free up resources, reduce the amount of work they do, the effort they invest, and also reduce the costs that they have. Now, to be perfectly honest, that's a goal that I find hard to achieve in practice, at least in the short run, because usually when you're going into the cloud, you're going to spend more effort and more money. However, the last point on my slide here, that is one that I would sign off on. Namely, the flexibility that you're able to gain by going into the cloud, the quicker reaction times, quicker time to market, and also quicker turnaround times. That is something that is certainly achievable if you're doing it right. And that's precisely the point. A lot of organizations struggle on their journey into the cloud. They might even fail. And that's because those goals, those benefits don't come for free. Even if an organization invests a lot of effort, a lot of time, a lot of money, a lot of resources into their journey in the cloud, into the cloud, they're still not guaranteed to reach these goals. Because not every organization is fit for the cloud. Some of them aren't. And the same goes for applications and systems. There are applications that are fit for the cloud, and there are those that aren't. And of course, certainly you can take almost any application, force it into some kind of container, lift it and shift it into the cloud. But the only thing that gets you is a label. Yeah? You can put the label cloud on your application, but it does not help you achieve any of these goals here. You need to have the right approach, the right strategy. And those 15 factors of success that I want to talk to you about are how to design applications or systems to be fit for the cloud, to be cloud native, such that you are able to reach your goals. And the first concept I want to introduce is the 12-factor app. Maybe some of you have heard about it already. It's a concept that was developed by Adam Wiggins of Heroku in 2011, so 13 years ago. And it's still important today. It's a methodology for building software as a service applications. And the great thing about this methodology, this set of 12 rules, is that those rules were designed to be independent of a programming language. So it doesn't matter whether using C# or Java or Python or whatever. Independent of service dependencies, and even independent of the cloud service provider. So not only specific to Heroku, but for any kind of cloud scenario, even for a private cloud. Now you might have noticed some discrepancy here in my slides. The title of my talk is 15 Factors of Success, whereas the concept that I just introduced is called the 12-factor app, and you might be able to read it on the right-hand side. It's a little bit small, but you might be able to count 12 factors, 12 criteria here. So what's the deal with that? Why 12? Why 15?
I said the original 12 factors are 13 years old. And since that time, people have used them and have found that they are necessary, but they are not always sufficient. And in 2016, so that's also almost 8 years ago now, Kevin Hoffmann of Pivotal, you might know Cloud Foundry, right? So that's something by Pivotal. He took the time to write a book about it, to reassess, reevaluate those original 12 factors, reprioritize them, and he also added 3 additional factors. And now 12 plus 3, that's how we come to those 15 factors. Now, my talk is inspired by this book, and I recommend that you read it. One thing I want to make clear is it's not the point or the goal of this talk that you memorize those 15 factors. I will quickly introduce each of them, tell you what the general idea is, but you don't need to memorize it. For that, you can Google it or you can read the book, right? What my goal is, I want to show up, especially some kind of ways to violate those rules that you might encounter in practice, so that in the future, when you encounter them, you spot them. You see that those are actual violations, that they might be problems, they might be technical depth that you are in that will prevent you from reaping the benefits of going into the cloud. So that's what I try to focus on here. So let's dive into that. First factor, one code base, one application. It's as simple as that. It just says if you have one application, you should have one code base for that, and vice versa. And how would you violate that, or how could you violate that? Well, a violation would, for example, be if you had one application built from multiple code bases, right? Why is that a problem? It's a problem because then it becomes difficult to automate continuous integration, continuous deployment, and even harder to keep your CI/CD pipeline stable in the long run, because things will change in different locations all the time. Even worse, if you go the other direction to violate it. The second example here, if you have multiple applications built from the same code base, meaning even from the same code repository, right? That's very bad for scaling your organization, because what you usually want to be able to, you want to be able to put different teams in charge of different applications. Now, if different teams work with the same code base, they will constantly infringe on each other's responsibilities. And it's very bad because it costs a lot of effort. It will slow down development significantly. It will cost a lot of communication overhead, and you cannot scale your organization that way. Third violating example, I guess I don't have to talk about that. If you don't use version control at all, well, that violates madness. In many of my slides, in addition to those violating examples, I also try to clarify things that in the past I found people struggle with understanding about the factors. In this case, it's not a violation. So that's not a violating example. The last point here, if you follow this advice, one code base, one application, you're done. It's not a problem if then you build multiple different deployments from it, multiple stages, multiple releases. That's best practice. That's what we all do, of course. Yes, certainly that comes with some complexity, but we have version control to handle that, right? So that's not an issue. That's not what this factor is about. Second factor, API first. I guess most of you have heard about API first, right? So that should not be new to most of you. It's also one of those 15 factors. And it's an important one because it comes so early, right? So I said it's prioritized as well. API first means you should invest a significant amount of effort upfront in designing your APIs. So before you start implementing them, not only when you start in Greenfield, but also during your iterations. First thing before you implement your user story is you consider how it impacts your API, how you should change your API, even if you should change your API to satisfy the requirement. That is what API first is about. Right? And you would violate it, of course, if you treated APIs as an afterthought, as a byproduct. Because what happens then? Well, what happens is your API will only reflect the implementation. And if it reflects the implementation, then you're leaking abstractions. And you certainly aren't going to properly address the use cases that your consumers, the consumers of your APIs are going for, right? So that's why you need to consider it first. Another example of violating is if you don't apply the same level of quality assurance to your API as you do for your application, right? So we all agree that we do testing, we do code reviews, we do static analysis, we use linters for our applications because we have all understood that those are important measures for ensuring quality of our applications. We need the same measures for our APIs because otherwise, obviously, the APIs will be bad. And bad APIs are a huge problem wherever you are with your application, but especially in the cloud, because you're going to use the cloud to integrate different systems, and they will be integrated via the API. So you need to be sure that your APIs are good and they are stable, right? Third example here of violating this factor is if you don't follow established standards, because then your APIs will be hard to use. Consumers won't be able to understand them, right? Another clarification here, so it would not be a violation, or let me phrase it differently. It's not an issue with agile processes. So when we're talking about API first, that is not waterfall. Some of you might perceive it that way. That's not what I'm talking about. I told you can do it in an iterative way. In fact, API first forces you to go into customer collaboration to find out what your consumers actually need. And that is right there in the Agile Manifesto. It's one of the 4 core values, right? Customer collaboration over contract negotiation. So that's not an issue here. Factor number 3, dependency management. It's really right down to the technicalities. Your applications need libraries to be built upon, right? You're not writing everything from scratch. Those libraries, those binaries that you're using in your application, you should explicitly declare them and you should take control over them. Right? Those are your responsibility. It's your responsibility to make sure that when your application is running, whether it's in development, in test, or in production, that exactly those libraries and those versions are used that you know work. And a violation of that would be the so-called mommy server. Sounds funny, I know, but it's exactly what you would expect it to be. It's some kind of host environment where you expect that it serves you implicit assumptions of what is installed there. Like you rely on some kind of global assembly cache, right? So that's a violation there because obviously that would make your application, your service not portable, right? If you try to move it to another server, your assumptions might be wrong there. Another violation is if you don't properly isolate the dependencies. This is about controlling which version is running, right? So that maybe in some kind of host system, there is some version of the library you need, but it's not the right one. Then that's, of course, also an issue because you all know these problems, works on my machine. You cannot reproduce what is happening in production, right? So that's the issue here. What this factor is not about is other service dependencies. This is just about libraries. Other services, backing services, are treated in another factor. We will get to that later. Factor number 4, design, build, release, run. That's a complex one, to be honest. That's also why we have so many potential violations. First of all, this factor tells you that you should keep those different phases separate, right? And you should consider these different artifacts as separate things that you can assign different responsibilities to as well. And it also specifically tells you that releases should be immutable and they should be versioned. And another aspect of this factor, it's really overloaded, to be honest, is it tells you should do continuous integration, continuous deployment automation, right? So that's why we have so many ways to violate it. It's a violation if you ignore upfront design completely. We talked about that when we talked about API first but let me go into more detail here. I've seen it a lot in practice. People are misusing agile practices to compensate for bad design. That's not what agile methods are for. Agile methods are for refining your requirements and for redirecting your application when requirements change. They are not meant to compensate for bad design. Bad design is something you need to address within your iterations, right? Otherwise, it will cost you a lot of money. It will cost you a lot of time because you're wasting agile processing or fixing your design. Second violation here, separation between build and release. So the build and the release are two different artifacts. Both of them are artifacts, but they have different properties. The build is agnostic of the environment it runs in. So it has no knowledge about the environment, and you can use the same build for different environments because it's not coupled to the configuration. What is coupled to a specific environment configuration is the release, right? Release is a combination of a specific build with a specific environment configuration. So that's the difference here. If you violate that, then you have a tight coupling between your code and your deployments, and you won't be able to port it to different environments, right? You won't be able to sell it as easily to another customer. Next violation here is if you have mutable releases. That's a catastrophe. You have a version 1.0 and it can mean different things, right? If you have that, you have no chance of auditing your deployments because you don't know what's running. And you have no chance of reproducing issues because you don't know which version of your code the release is based on. So obviously you shouldn't do that. Releases should be immutable and you should always be able to roll back. Lack of CI/CD automation. So you won't be able to scale your deployments on an organizational level. You won't be able to scale to hundreds, to thousands of services if you don't automate your releases. Also, again, you have a lack of reproducibility. You have a lack of quality. It will be error prone if deployments are done manually or builds are done manually. And the last violating example here, that's about separation of code and configuration. And it is valuable to talk about that in more detail, and that's why there's a node factor for that. Dedicated factor number 5. It's about configuration, credentials, and code. And it simply says you should keep those 3 separate, especially configuration and secrets separate from the code, but also treat secrets differently than the rest of the configuration. Because if you violate it, if, for example, you store the configuration of the different environments your application will deploy it in the code, then again, you have this tight coupling, right? It will be more difficult to port your application to different environments if those are coupled so tightly. And another violation would be if you stored your secrets without proper access restrictions, right? You don't know who in 5 years and 10 years will have access to your Git repository. And even right now, I would wager that not everyone who has access to your repository should have access to all the secrets. So you should keep them separate, just use some kind of vault or secret store there. Because otherwise you will be leaking secrets and you run a high vulnerability risk here. Just try and Google or Ecosia it once. Try to search for secrets on GitHub. You'll be surprised how many you will find. Of course, many of them are dummies, are only used for testing, but I would bet that at least 1% of them are used somewhere in production. One thing that isn't a violation of this factor is default configuration. So in your code, you usually have some kind of default values, right? That's the standard way of implementing default settings. That's not an issue here. This is just about the environmental configurations. Next factor, logs. So this is about logging. It actually has 2 aspects here. First aspect is you should treat your logs as proper, well-designed, well-structured streams of events, of messages, just like you would implement communication, asynchronous communication between different systems, right? A log message is an event. It's just like an API. You should be able to have stable structure of log messages such that you can automatically evaluate them. The second aspect of this factor is you should rely on the host environment to deal with the logs that you're writing. You should not implement your own logging solution. If you do that, then first of all, you're mixing up responsibilities, right? Your process has some function that it's supposed to serve, and it's not your job to implement logging in there. And it's also bad for portability because a lot of custom-built logging solutions will be tightly coupled to some kind of storage. For example, the file system. A lot of cloud service models do not provide you with a file system or force you to use a very specific type of storage. So you lack portability if you do that. Another violation would be if you consider log messages only as second-class citizens of your application, of your data, because then you will not be able to properly automate processes around evaluating, about alerting that, right? And you won't be able at all to implement self-healing processes for your applications, which you absolutely are going to need to be able to scale to hundreds or thousands of services that your organization wants to handle, right? What's not an issue here is if you just integrate or use some standard logging solution, as long as it enables your host environment to configure your application such that it can collect your logs. Next factor, disposability. Actually, that's my favorite one because that's such a nice analogy here. What this factor basically tells you is your applications, your services should behave opposite to your standard teenager. Applications should start up quickly instead of staying in bed indefinitely. They should shut down quickly instead of staying up late. And they should clean up after themselves, right? If you violate it, if the application doesn't clean up after itself properly, for example, if you're implementing your own locking, not logging, locking solution badly, and usually it's done badly if you do it yourself, then you will leak resources. Once there's an error, once your program crashes, then logs will stay open, you will leak resources. So that's a violation here. And another violation would be if you tolerate high startup times. Any of you running Spring Boot applications with 30-second startup times here? Well, don't have to show up, but that's an example, right? You will be unable to handle load spikes dynamically then. The load spike is long gone when you wait 30 seconds. Your customers are all dissatisfied by the time the application starts up. And also the other side here, your application doesn't shut down quickly enough. Then first of all, that's a waste of resources. You want to use the resources as soon as you instruct the application to shut down for another process. And second and worse is, at some point, the host system will no longer wait for your application to shut down. It will just kill it hard, right? And if there's some data left in your memory that you have not committed, that you have not sent to the backing service that's responsible for storing it, then the data is gone. You might have data corruption there. Right. Next factor, backing services. Right? So we previously talked about libraries. This is about backing services. So we have dependencies that are not local to application or that are not binaries, that are external services. Of course, you have them and you need them because no application is an island, right? And this factor tells you that you should explicitly declare the service requirements that your application depends upon. But you should not bundle them with your application, obviously, as opposed to the libraries. You should enable the host system to trace and to track the availability and make sure they are available to you. You would violate them if you didn't declare them, because then, first of all, you would run into boot order issues, right? So your application would be considered to be ready before your required services are up. So that's an issue. And you would also run into the problem of being able to know the relationships between the services. So if I want to change one of your backing services, I don't know that you depend on it. I don't know that I need to interact with you to tell you that something's happening there, right? And thirdly, it prevents proactive troubleshooting, right? It's so easy if you have this declared dependency, if one of the backing services go down, is that I tell you, take care, there's a problem here. You might be impacted by it. If you don't know, then I won't tell you about it, right? So that's an issue too. Another violating example is if you try to spawn those backing services yourself. You're not responsible for them. Other teams are responsible for it. I'm really sorry that you have to readjust the camera all the time. You're not responsible for them. Again, we had that previously. Other teams need to be able to have their own separate responsibilities that you can scale on an organizational level. You violate it that way. Also, you have tight coupling of deployments because you need to deploy them all together, right? You also don't want that in a cloud environment. And of course, it's also bad for scalability because you can't scale up individual services, then you would scale them all together, which is a waste of resources. Factor number 9, environment parity. Environment parity, I guess from the title, it seems pretty obvious, but it has several dimensions. It has the dimensions of differences between the different environments in time, in the human dimension, and also in the technology dimension. So it would be a violation if you had excessive gaps, time gaps, between implementing a feature and putting it into production. Because then once you put it into production 6 months later and something goes wrong, you have a high effort of remembering and understanding which changes might have caused the issue, as opposed to having quicker cycles. And regarding the dimension of people, that's just a basic DevOps thing, right? If you have a dedicated ops team for your application separate from your dev team, then you have this classic issue of the knowledge gap, of the operability gap, right? The silo issue. People who are supposed to operate the application don't know what it's used for. At least they don't know the details. And the people who develop it and are not responsible for operating it don't know how to make or what to do to make the application operable, right? So that's why DevOps is such a big topic here. And the third dimension, technology, I guess that's the obvious one. If you have different tools or different tool versions between the different environments, then again, or even different technologies, then you have this problem of works on my machine. We had it before, right? Versions don't match, then you don't know what an issue is caused by. Is it caused by a bug in the code, or is it just down to a different version, different tool? What is not an issue, I guess it's clear to most of you, is site reliability engineering, but let me mention it because I've had some confusion when I taught people about that in the past. Some people assume site reliability engineering is an ops team. It's not, right? Site reliability engineering is about automating operating processes, among other things. So that's precisely one of the methods, one of the measures you can take to eliminate the gap, the human gap here, the second part. So that's a good thing, not a problem. Factor number 10, administrative processes. That's a complex one. And that's actually one where in this modernization that was done by Kevin Hoffmann, where he changed the most about the original one. Because the original one was a little bit focused to deployment or hosting models similar to Heroku. What this factor in the modernized version says is you should treat perceived one-off tasks with the same best practices as the functionality of your applications, right? And on top of that, you should always consider whether such a perceived one-off task is still worth automating, because maybe it's not really one-off. Maybe it's something you will use again, you will need again. An example of violating that, for example, would be if you ignored the requirement for the best practices, because you probably can imagine most of these administrative tasks run in high privileges, and they are usually also high-risk operations. Now, if this high-risk, high-privilege operations are done with bad quality, with bad processes, then it's a high overall risk you're taking. You don't want that. You want best practices there as well. And the other way of violating that is if you misinterpret tasks that are actually repeated tasks as one-off tasks. Classic example that I see time and again in practice and projects is if people think that database migrations are one-off tasks. Surely, applying one migration, one environment is a one-off task, but you use it in several environments, and you will have in the next iteration another set of database migrations you want to execute. So that's a process you need to automate. That needs to be part of your deployment, right? If you violate that, then you actually have the same problems that we had in the previous example again, right? You have bad quality of those high-risk operative tasks or administrative tasks. What would not be a violation, so to clear up this, is if you go even one step further, right? So now you consider a certain administrative task and you think, well, it's actually worth automating that, implementing functionality. And then you think about, should that actually be part of my application, or is it worth its own service, its own application, right? That might sometimes be useful, might sometimes be not, depends on the scenario. If you decide you want your own application for administrative processes, go ahead with it. It's not a violation. Factor number 11, port binding. So previously we talked about backing services, so we know we have some service dependencies. Now this is about how we should use them, how we should communicate between different services. This factor, this rule, tells us that we should design our services such that they can be consumed via ports, via the network, and in a configurable way, such that the host environment can control over which port it will communicate with our service. And second of all, we should also ourselves consume other services via the network, not via hidden integration channels. Let me go into the violating examples. For example, if you hard code port assignments, that's obviously bad because it's bad for portability, right? So that shouldn't come as a surprise to you. But also, if you micromanage port assignments, even if they are not hard coded, that just doesn't scale. You can do that if you have, let's say, 10 services, but you can't do it for 100, and especially not for 10,000, 100,000 services in your organization. You need automation for that. You cannot micromanage it. It's bad for scalability. And the last one, maybe the most difficult to grasp, is if you are forced in such a one-to-n relationship between a container or port and number of n applications that always need to run together, because it's a strong indication that you're not communicating over the network, that you use some kind of hidden integration channel between those services, maybe via the file system, maybe via some internal pipes, where you cannot apply the standard tools that you have to control network communication, and where you cannot have the host system control which service instance communicates with which other services. So that leads to fragile systems. Factor number 12, stateless processes. I guess that shouldn't come as much of a surprise to the senior software engineers in the audience or to the architects. It says you should structure and design your applications that they do not track state, local state in the process beyond the scope of processing a request or beyond the scope of handling an event, right? So you can do whatever you want during you handle such a request or event, but you should not expect a certain state before, and you shouldn't track a certain state afterwards in your local memory of the process. And the violation, of course, would be if you did track such a state, such a history of calls in your local memory. And the problem with that is that you will fail to get good scalability, and moreover, it will be very difficult, near impossible, to get good availability, because what happens if your process with this functionally relevant local state crashes? And then all the consumers that rely on your service on this local state there are in an undefined state, right? So that's very bad. So now you might be wondering, well, but our applications obviously need some state, right? We are all shoveling data around. That's what we're doing. So obviously there is some state in our systems, but you can externalize that state. It's pretty elegant, and to be honest, pretty underused. You can externalize some state to the clients. That's often a good idea. If you look at REST, that's one of the principles there. But obviously, you also have the option to externalize state to backing services, for example, into the database or other service that you're consuming. That's fine. That's not a violation. You can always do that. And if you implement your cookies that way, then you can also use cookies. But those are prime example that usually violates that principle. That's why I have this icon here. Factor number 13, concurrency. This is about, I talked a lot about scaling. This is about how you should model how your application should scale to handle higher throughputs. And it clearly states that you should not do, if you look at the figure here, you should not do vertical scaling. You should not design your applications to scale vertically, but you should scale them to design them to scale horizontally via the process model. And the reason for that is because vertical scaling has a hard physical limit. At some point, there is no more powerful machine, no more powerful hardware. And long before you reach that, in most systems that you're going to build, there's a much lower economical limit, because costs do not scale linearly with power of infrastructure, right? Probably you have experienced that yourself. What is not a problem is if you follow that advice, if you are able to scale via the process model, and then on top of that, build in more parallelization, more concurrency inside the process, make the process itself accept more throughput if you use the thread model in there. So that's not a violation. You can still do that. Just in general, you should be able to scale via the process model. Factor number 14, telemetry. How am I on time? Oh, I'm good on time. That's great. Factor number 14, telemetry. This one, again, has two aspects. So if I would write a book on it, I would probably split it up in two different factors. But let me tell you what it's about. First of all, it's about you should implement, on top of the technical monitoring that probably all of you are doing anyway, you should implement functional monitoring, KPI tracking, dashboarding for your applications, for your processes. And the second aspect is you should also, when you have a distributed system, you should have comprehensive tracing, not only individual processes, individual applications, but also tracing across different services, just like you would build not only unit tests, but also integration tests, right? It would be a violation if you rely on in-process debugging. You can still do in-process debugging on your local machine, but you won't be able to do that in most cloud environments, right? So cloud hosts won't support that. So you should have other techniques for troubleshooting your application. And it would also be a violation if you only rely on technical monitoring. It's not enough to see whether an application is up or down. You need to know what's happening, functionally happening. You need to be able to answer the question, how many users have used your product in the last 10 minutes and the last hour? How often did you go through a use case? So how many use cases you did process? How many errors appeared there, right? So those are KPIs that you need to track. If you don't, then it will prevent ops automation, and it will prevent you from implementing self-healing techniques, right? Because you don't have enough information to implement them. Sure, if you have technical monitoring, you can restart an application once it crashes, but it's very basic, right? With KPIs, you can do much more. You can do alerting. You can proactively react to issues in your system once you notice that behavior of your application does not match your expectation, so that you can troubleshoot before the customer complaint comes in 3 days later. And it would also hinder empirical efforts of improving your product, right? You need to constantly match whether your expectations of how your product is used are actually correct. Maybe you can find new features that you can sell to your customers. Maybe you find out that you implemented something, misunderstood some requirement. You could do it better. It's only possible if you track KPIs, functional KPIs. And another violation would be if you don't implement comprehensive troubleshooting. Because if you have a highly distributed system with tens or more services, it's extremely costly to try and find out where it went wrong. Right? You need to be able to trace requests. You need to be able to trace events when which service did what. And an example of implementing that pretty easily is by using OpenTelemetry. That's why I put their icon in there. Right? And the last factor, factor number 15, it's about authentication and authorization. Now, it sounds complex, but it comes down to pretty easy rules. First of all, shift left security. That's also something you've probably heard of before. Similar to API first, you should design security in your application, not use it as an afterthought. Because if you consider security as an afterthought, late changes in the development stage are extremely costly. And if you rely on a pen tests are a great thing, but you're going to miss things. And that's even more expensive if you have a production vulnerability. Another aspect here is the factor 15 tells you should rely on standard tools, on standard practices, standard procedures. For example, OAuth 2 is such a candidate. It's widely spread, widely accepted, and also widely tested. Or using role-based access control. Those are industry best practices. Use them. Don't roll your own security solution. If you try and roll your own security solution, you are going to get it wrong. It's extremely difficult to get it right. And on top of that, considering the aspect of going into the cloud service providers won't support your custom solution. They have their standard solutions, and you need to be able to plug into them, right? And lastly, if you don't follow established standards, if you rely on obscurity, then I guess that's not a surprise to you. Obscurity is not security, right? That shouldn't be new to you as well. So those were the 15 factors. I know You won't be able to memorize them all. That's not a problem. You can just Google them or can you read the book. It's actually a short read, like an afternoon or something like that. I can recommend that. I hope I was able to convince you that sure, you can take an existing system or application, put it into a container, lift it, shift it to some kind of cloud service hosting model, to some hyperscaler, but you won't be able to gain the benefits that you hope to achieve if you don't have application systems that are ready to work well with the cloud. And I presented 15 factors that show you how to do it right, that show you what to consider. And if you can't remember them, I hope at least I was able to achieve my goal of making you get a feeling that you encounter, if you encounter some of those issues that we addressed in practice, that you feel something's wrong here. Just like with code smells, right? You know, code smells, and those are cloud smells. Thank you for your attention. Do you have any questions?